All right, I have it as to be officially 2 p.m. So hello, everybody. My name is Abby Bristol, and I'm from Van Buren Conservation District, and I would like to welcome you to our second Backyard Symposium. This week-long series is designed to help landowners of all sizes bring their yards to life as a beautiful, sustainable part of our environment. From backyards and lots in urban areas to rural homesteads, green space is beneficial for our mental health and our physical health, and for the animals and plants we share our space with. Through the series, we're hoping you can learn actionable, approachable ways to make your space a bit greener. In the chat, please introduce yourself and share what you would like to learn, and feel free to interact there throughout the presentation. By default, all attendees are muted and have your cameras off. This is to allow us to record these presentations and then be uploaded to our YouTube channel for those who couldn't join us today. So today we will be welcoming Chris Imler. His presentation is called "Don't Spray, Let the Insects Pray." Again, welcome to the Van Buren Conservation District's Backyard Symposium webinar series. Message us using the contact form on our website, vanburencd.org/contact-2/, or you can sign up for our newsletter using the subscribe option at the bottom of our website. This webinar is being recorded. Recorded webinars will be posted next week at our YouTube channel, youtube.com/vanburencd/videos. Follow us on Facebook at Van Buren CD. Live captioning is available. You can activate that using the little CC button at the bottom that says closed captioning. When we get to questions, please utilize the Q&A icon. You can find that at the bottom of the screen to submit a question to the presenter. Type your question in the box and click the send button. Questions will be asked by the moderator at the end of the presentation. If you need help, please use the chat feature. You can see the chat button at the bottom of the screen to reach out to me, the VBCD moderator, for help using Zoom.
Okay.
I want to get a good intro started for you, Chris. So today, Chris will be speaking to us. Christopher Imler is a horticultural educator with Michigan State University Extension. His work in Southwest Michigan aims to improve public horticulture knowledge and practices with an emphasis on environmental and social sustainability. I'm going to stop sharing my screen, and you're welcome to take it away, Chris.
Excellent. Okay. So, okay, we're gonna see if we can't get the appropriate view here. How does that look?
Looks great. I see everything.
Okay, and I'm just gonna move all my little Zoom doodads around. Okay, here we go. And what a solid picture to start off with, by the way. I titled this presentation the way it was because I really wanted to focus on an idea that may have been lost in translation at some point in the public corpus, in the body of knowledge that we all kind of assume is true, which is that if there is an insect problem in the garden, sometimes the best thing that you can do is absolutely nothing, right? Asking somebody to do something so counterintuitive without giving them any additional information that's a difficult ask. But for the last 8 months or so, that's exactly what I've been doing. That's exactly what I've been preaching. Some of you in the audience, I recognize your names, might know me from my township hall appearances. In the last year, one of the biggest pest issues that we've had in Southwest Michigan is the Lamatria dispar moth, formerly known as the gypsy moth. It's pretty pernicious, right? If you had it, you know you had it. If you haven't had it, you will. But the interesting thing about this moth issue is that although it's particularly irritating, it can make your home and your immediate environment look quite bad. Really, the number one suggestion that we give people is if you can, do nothing, right? because over time, the natural forces that kind of will this pest back into the shadows, as it were, it takes them time to ratchet up and to kind of increase their pressure, but it does happen, right? So we're going to talk a little bit about this kind of philosophy of doing nothing and how to effectively do nothing. MSU is an affirmative action, equal opportunity employer. If you are reviewing this later, please take a chance to look at our policy regarding how we'd like to deliver our educational content and how we try to make sure that we're reaching all the different and diverse audiences that make up Michigan, right? It takes all kinds of people. I can just sit and kind of talk at you about what natural predators are and try to kind of paint a nice word image, but I think I'd like to go ahead and start with an actual video here that will kind of immerse you in the process that we're looking at, why it's so important, and then we're going to kind of revisit the terminology that comes up in this video. So go ahead, put your headphones on, and then for the next minute or so, we're going to take a look at this. Really, I think one of the best, the absolute best pieces of footage from National Geographic.
I don't hear it anymore, Chris.
No problem. Here, this is what we're gonna do. We're gonna go to stop share. We're gonna hit share again. We're gonna hit sound share. Okay.
Good.
All right, how's that?
Our parasitized
Sounds good.
caterpillar has spent the last 12 days gorging itself. It now appears profoundly obese. But this is not all fat. The glomerata wasp larvae lie just under its skin. Each is the size of a grain of rice, but together they account for over 1/3 of the caterpillar's weight. The larvae have not yet finished growing and need to keep their host alive. So although they feast on the caterpillar's blood, they have been careful not to touch a single one of its vital organs. This uneasy truce will not last. Within days, the larvae are fully matured. Suddenly, they begin to stir into action. For the past 2 weeks, this surrogate womb has protected them, but now they no longer need it. To complete the next stage of their life cycle, they must break out.
All right, we're gonna hit pause there because I don't want anyone who's squeamish in the audience to have to sit through that. Needless to say, what we were about to witness, it's still going. What we were about to witness was the emergence of a parasitic organism from a caterpillar. Some of the really interesting things that the narrator touched on, right, was that the parasite living inside this caterpillar made sure to not immediately kill it right away. What that tells me is that this is a pretty complex parasitic relationship, right? Because in simple parasitosis, right, the parasitic organism might eat something from the inside out and just use up whatever calories it can get, and then move on to the next stage of its life cycle. But in a more complex process here, we have the organism that has kind of almost co-evolved with its host to prolong that parasitic process and to get more food out of it. All at the same time, it's inhibiting this host insect, which is the prey, right? It's inhibiting its ability to grow adequately, right? It's inhibiting its ability to reproduce because it has diminished growth. And then it's also eventually going to just kill the insect right out. And I used an example of a predator for here. I used an example of a parasitoid, which is a very special kind of natural predator insect, because once they lay their eggs and once they begin that process, it's so very effective, right? And that's just to illustrate the real strength that nature has in the turnover and kind of the balance of organisms, right? We tend to see, you know, insect infestations as kind of this overwhelming, unyielding force, but in truth, anything that's out in the garden that is eating something also has something eating it. So the reason why this topic is so relevant currently is that the general movement of pesticide registration, pesticide options, is moving towards fewer chemical routes for consumers, and the options that are kind of left have more specific limitations on how those products can be used, right? So there's going to be a big emphasis in the future towards a more holistic approach. Maybe some of you are familiar with IPM, integrated pest management, but we're going to do a brief review of that and then talk about how biological controls or natural predators kind of fit within that overarching scheme, right? So we'll talk about IPM. Let me get my little laser out here. Love a good laser. Okay. So we'll talk about IPM a little bit. Uh-oh, where'd my laser go? Here we go. So we'll talk about IPM a little bit. We'll talk about how beneficial organisms fit within an integrated pest management plan, specifically how predators fit in, and what we can do as gardeners and ranchers and landholders to support those natural predator species, right? We'll talk very briefly about some indoor plant considerations, because I know some of you are indoor gardeners. And then lastly, I want to leave you with the tools for you to continue your education within this topic. I really try to avoid talking about rote information and scientific facts as much as I prefer to focus on scientific concepts so that you have the tools to kind of fill in the blanks as we go, because I'm going to talk about things today that maybe don't apply to you as much, but the concepts, right? The overarching concepts that we talk about will be universally applicable. So by the end of today's presentation, you should be able to explain biological controls. You should be able to describe how to use predators in gardens, and then identify resources for future reference, right? So let's start out with laying out just some foundational information here. And if this looks familiar to you, or you're like, oh, Chris, I already know all that. That's college horticulture. Well, good for you. And we're gonna applaud you while we catch the rest of the audience up to speed. We'll start out with this kind of just initial guiding principle is that one, all pest organisms, whether they are insects, whether they are any kind of arthropod, right, which is what insects belong to, arachnids, from a horticulture perspective, weeds are also considered pests, right? So a pest is any living organism that we do not want, right? So a fungus can be considered a pest as well, right? So the major consideration that we want to make here, regardless of whatever kind of pest management plan we have, is that all pest organisms have distinct life stages, right? They have generally at least 2 or 3 distinct life stages, right? So distinct either morphologically, right, in the way that their body looks, or physiologically, right? Are they of reproducing age? So based on those life stages, our decisions in terms of how we prevent their infestation and how we eradicate them once they're there changes wildly, right? So that's one piece of information that we absolutely have to integrate into all the decisions that we're making. Second, plant pest problems are solved by controlling the host, the environment, or the pathogen itself, right? We refer to this concept as the the pathogen management triangle, disease management triangle, right? So for example, I could have something like Monarda in the garden, right? And I absolutely love Monarda, but I know that there's a certain time of the year where it's going to get some kind of mold on it, right? Whether it's a powdery mildew or a downy mildew, always happens, right? So I've got my host, which is my Monarda. I've got my pathogen, which is my downy mildew, and then my environment, right? So the last bit of this is really crucial. It's one of the things that we can control most. If we're having a plant pest problem, right, we generally don't want to decide, okay, well, I'm just not going to grow this plant anymore. You can if you make it a priority, if you make other plants a priority, but really we want to look right here at the environment. Now, I know that when my Monarda gets mildew on it, that, you know, it's maybe time to cut down the Monarda and start getting rid of the infected debris, as opposed to reaching for the spray bottle each time it happens, right? Because I know that the environment that Monarda is being infected in, it's going to happen again next year, and it's going to happen again next year, and it's going to happen again next year, and it's a completely naturally occurring event, right? Okay. And then this third idea that we want to integrate in all of our decision making is that plant pests have consistent hosts, changes in population size, and signs, symptoms of infestation, right? And so what this speaks to is our ability to predict how bad a pest is going to get and really when we need to do something, right? We know that certain plants have certain sensitivities to certain pests. We know that certain pests can increase faster or slower than others, and that their increase in population size and just their existence in general are going to leave signs and symptoms, right? So signs are physical evidence that they were there, and it can be dead bodies, it can be frass, which is just a slang for insect poop, or they can leave symptoms, which are changes to the shape or the condition or the quality of the plant that kind of cue us to these pest pressures, right? So 3 principles here, right? One about life stages, one about the things that we can control, and then kind of how we can predict that insect growth. And we integrate these ideas into an overarching practice called IPM, or Integrated Pest Management. There are a lot of there are more definitions about what IPM is than I can review today. But at its very crux, right, IPM is a long-term strategy to reduce pest damage through planned control methods, right? And I put multiple control methods here because really, when we look at the recommendations for IPM, for integrated pest management, there's almost always the recommendation that you need to be combining your approaches. You really shouldn't be doing just one thing, right? IPM activities include prevention, so making sure that there are no pests in the immediate area in the first place, that you're removing diseased material, that you're inspecting plant material as it comes in, right? Monitoring plant populations, pest populations, and then kind of basing your control activities, right? Whether it's any of these forms here, basing your control activities off a threshold. And what I mean by a threshold is a line in the sand, as it were. So if I tell myself that my threshold, right, my tipping point is that if I see 5 aphids on a single leaf on a tomato, just throwing some numbers out here, that is my threshold to begin cultural control, which could be a million different, pruning, right, moving plants around. And then if I see even more aphids, that could, because this technique hasn't worked, I can move on to progressively more severe and then potentially interfering activities, right? So as we look at the forms of control here, right? So we've prevented, we've monitored insect populations, and then we're going to do a threshold control. We start out from generally mild, right? So a cultural control, changing the way that we grow the plants, to a mechanical control, physically removing the insects off of them or trapping them. A biological control, which is the emphasis of today's presentation, right? A biological control is just the introduction of an organism. And then a chemical control, which is, I think, probably what people are most familiar with, right? You see aphids, you see something on the plant, you go to Lowe's and you grab a bottle of neem spray, right? Well, I hope that after today's presentation, you will think about a chemical control option as not necessarily a completely hands-off option, but maybe the last option that you should resort to before trying these other things. Because if you're in today's audience, you're here to learn more, and you're here to kind of gain more advanced skills. So hopefully you can adopt some of that. So with all the information that you'll see online regarding IPM, and maybe you've seen some YouTube videos, a lot of people are still left wondering, okay, well, how do I do IPM? I've heard about what it is, I've heard about different activities, but how can I put together a basic IPM plan? And I try to present this next information here from the perspective of a homeowner, because IPM professionals have a lot of resources. They have time. They have dozens of people working for them to go and find these creepy crawlies, whereas you might just have you. So I tried to make this as easy as possible. 3-step process here. 1, know what you're growing, right? And know what the pests are, right? 2, write down important dates and control options. So if you know, for example, when a species is going to be reproducing, probably an important date to know, right? You don't really need to know down to the exact day, but you should have as specific as you care to get a timeline. And then also control options that are associated with that pest at the particular date. And then lastly, you want to schedule time to do IPM. IPM is an activity, and like anything else, if you don't block out time to do it, you're just not going to do it, because it's just one of those things that kind of gets swept under the rug until it's too late. So, but it's a proactive process, so you need to be putting aside a little bit of your gardening time every week. Again, gardening is an endeavor that happens in spite of you. Does not happen in spite of you. So let's take a look at how this might work. Let's say that I'm deciding to grow cucumbers this year in my garden. I've done it before. I love it. But I know that in the past, man, I really had a problem with squash vine borer. That's a really common insect amongst cucurbits, So, okay, I know that squash vine borer is a problem I had last year. So I'm going to look up, all the related species, right, including my squash vine borer, and then look at the things that are being recommended to prevent those things ahead of time, right? For my squash vine borer particularly, I have access to really good information regarding important dates. So dates like emergence, dates like egg laying, right? So the beginning and then the decline of egg laying, right? If you have never used it before, Michigan State University has a fantastic resource. It's called EnviroWeather. And EnviroWeather will, based on the information that you put in, like a zip code or a city, it'll actually tell you their best mathematical model for when certain things are going to happen for those insects. So for example, my squash vine borer, right? We know that on 6/11, right, June 11, we're going to have that adult emergence. So if I'm using a product that says it is a pre-emergent product for squash vine borer, probably important to know that date right there. Okay, so we've done our foundational work. Oh, we have some chat here. Oh, thank you for putting that in the chat. So we've done our foundational work, right? We know what we're going to grow. We know the common pests, right, for our area. Make sure that you're using Michigan information. Every state has its own extension agency, but I don't think that the facts that you're going to get from University of Florida are going to be quite as relevant to Michigan, right? Because we have a strong enough winter that overwintering pressure, right, is a significant determinant of insect growth and insect distribution. Okay, so we've done our first 2 foundational steps. We got all the information that we got as locally as we can, and then we've scheduled our time to monitor the population size and life cycle. The 2 different ways that we can monitor or scout, that's the word that we use professionally, is passively and actively. So let me see if I've got it here. I've got my 2, if you look at my video, my tiny little video square, I've got my 2 different types of sticky trap here, right? And you can see it in the presentation as well, right down in here, right? These little sticky traps have grids on them. And we basically, in the commercial world, we use those grids to kind of count over time how the insect populations change, right? Something else that we can do is an active scouting, right? So by active scouting, me and the members of my team or whoever are going into the plants, and we are really digging into the canopy, and we're getting into the areas that are going to be conducive to finding preys. So areas like tender growing points, anything that's growing rapidly, any young tissue is very nutrient dense, right? In terms of access to the phloem, which is where all the sugars are. Looking at the undersides of leaves where prey insects might be hiding, looking at the surface of the soil, digging a little bit into the substrate. Those are your real hot spots, right? And it's important to be doing both of these things, both a passive and an active scouting program. And the reason why is that you absolutely cannot sample all of the plants and scout every single flower and leaf that you can reach in the garden, right? So you're going to have to extrapolate that information a little bit. But when you extrapolate, when you make these kind of assumptions based off one flower or one leaf, there's a big gap in the story that you're telling yourself. And so to fill that gap, we can use some passive scouting. So I'm recommending a combination, right? There's a call to action here. Schedule time to both do your active scouting and then also to put up and replace and count sticky cards, right? You can't leave these cards out here for too long, because what'll end up happening is all the insects that get on there, right, will make you think that, oh, you know, these sticky traps are doing a great job. They're catching all the insects. I don't really need to do anything. But here's the thing. For every one critter that you see on this card, there's about 10 more in the greenhouse or in the garden or elsewhere, right? So if you're waiting and just hoping that the trap itself is going to do something in terms of knocking down that population, you're going to be waiting a long time. All right, so let's say that at this point in your plan, you've determined that you're going to need to do some kind of control, right? We did our 3 steps. We made our IPM plan. We're monitoring our pest populations, and we're thinking, okay, wow, it's really getting out of hand. We need to do something, right? Pests and their respective preys exist at pretty low static populations in the wild, okay? Because their population, their numbers have adjusted according to the resources and the conditions of that area. They've adjusted to each other, right? Because one's eating another, right? And we can see an example of that relationship here, right? So if we look at this axis here, right, the up and down, that's the population density. So high, that's a high number. Low, that's a low number. So what we can see here is that as the population of a prey insect or a pest insect, in this case, increases, right, so too does the population of the predators, right? So this is the most numerous the prey will get, and this is the most numerous that the predators will get, right? And so we're going from time increasing, right? So the beginning of the month, the end of the month, or the beginning of the year, the end of the year. So 2 things should stick out immediately, right? 1, predator populations, the maximum population tends to lag behind prey, all right? So that's observation number 1. 2, predator populations, when they do increase, the rate of increase is slower. So if we look at the prey, right, this is a very steep curve. It's climbing rapidly, okay? And it hits that peak, but then it begins to decline as well. Whereas the predator, it takes a little bit longer, right, to reach that peak here, right? It doesn't just immediately come over and then immediately go up, right? So predator population establishment generally takes longer, and also the number of individual predators is going to be lower than the number of prey, right? That should be intuitive, right? There's, you know, we're talking hyenas and zebras here. There's got to be more zebras than hyenas. Okay, so that's what we expect from a natural kind of balanced pest predator interaction. Okay, biological controls, which are basically predators in this situation, they can be a preventative control in the sense that if we know, right, that we're going to have this kind of big increase in pest population right here, that we can augment a natural predator population by artificially introducing it earlier or creating habitat so that it's more conducive for those organisms to move in, so that we're pushing this crest here and this crest here. We're kind of pushing them down, and we're getting them closer together so that we're getting lots and lots of predators right around the same time that we expect our prey numbers to increase, right? In the absence of any real significant damage to the plants, right, if it's just more of an inconvenience, this ebb and flow is totally normal, right? It's absolutely natural. And you really want to leave it to be that way as much as possible. Otherwise, you risk creating an imbalance, right? And that may be difficult to anticipate and might be difficult to control. Now, a scenario, an asimilar scenario, right? So a scenario that does not follow this will be when it's a truly invasive species, right? And so this population dynamic works such that where we would have this downward inflection over here, what we essentially get is a tapering off. This is called carrying capacity. Basically, an invasive species comes into an area, right? It's multiplying, and then it seems like it just kind of holds steady at this one population number. And it's holding steady here because it's adjusted, but it's not adjusted to predators that are in the area. Really what it's only adjusting to is the amount of resources, the amount of food in that area, right? All right, so beneficial organisms, that's the umbrella category that we put predators into. Beneficials in the context of today's presentation are really, any creepy crawlies which kill, decrease the reproductive rate, or inhibit essential life functions of a pest species of interest. So this can occur in a lot of different ways, really fascinating ways. The first way that we saw at the beginning of this presentation was by parasitism, right? Parasites are an organism that live inside another organism, feed upon it, and then emerge. A parasitoid, however, is the organism which is implanting parasites into that prey, right? So mommy wasp, baby wasp, right? It can also occur just by simple predation, right? So an example here is a ladybug consuming aphids, right? So we're just introducing something that's just going to eat anything that's put in front of it, right? Or eat any of those prey insects. Now, something important to note here is that parasites and parasitoids, really, we were only considering the ones that can cause significant interruptions to those life processes of the pest insect, right? Otherwise, it doesn't make a good biological control. So even though we saw this example early on of an insect that eventually does kill its host, some insects will, persist in a host, complete their life cycle and emerge, but still not, for example, negatively affect a reproductive ability. And that's what we want out of our predators. Lastly, a minor source of control can also be competitors, which compete with other species that are not beneficials. An example would be a dung beetle, which can successfully push a pest species out of a habitat substrate. So if this dung beetle, for example, could be disturbing some animal manure in such a way that makes it inhabitable to an organism that would come in after it, right? So a lot of different ways that we can incorporate beneficial organisms. But regardless of what we use, what the mode of action here is, predation, competition, parasitoidism, they still need to be combined with other forms of control, right? The reason that we're so interested in these and that why they're being pushed as like a better approach to overall IPM is that relative to, chemical and other mechanical forms of control, they can pose less of a risk to human and environmental health, right? When used properly, just like that. So I said I wasn't going to fact dump on you today, but just so that we have a kind of a good base point, good starting point. Two Michigan natural predators that you'll see quite often are black ground beetles, different kinds of ground beetles, and the decinid fly, right? And they each have their own kind of preferred diet of prey insects. But really, a lot of the species and a lot of the practices that we're going to talk about that preserve these insects and that provide them with the things they need to do their job, they're going to be the same. The considerations are going to be the same. Not so much in the sense that one plant that I put into the landscape for a black ground beetle is also going to be perfect for this fly, but in terms of spraying practices and timing your pesticide that you put out there, and then how you approach sanitation in the garden. So, right. So all the things I just mentioned, right? So we've talked about incorporating predators as a practice in your IPM strategy here. So what are your tools, right, for supporting predators? There are three main approaches here. Getting smarter with your spraying. Again, it really is up to you as a consumer. It's up to you as an environmental steward to decide the appropriate amount of spraying. It's almost impossible for you to tell me, for example, your situation that you have at your home, the challenges that you're dealing with, and for me to come up with a custom fit plan for you over the phone. You're going to have to do your homework, right? Cultural practices, the choice of what you're growing, how you're growing it, when you're growing it, play a huge role in the conservation of natural predators. And then also the conservation and creation of habitat, right? So just like prey insects, predator insects need a place to go to shelter themselves from adverse environmental pressures, and then also to get them through the winter, and then to reproduce. So let's take a look at this first issue. If you are struggling in your endeavors as a gardener, you just started, you don't feel like you know enough yet, you don't have to completely cut spraying out of your toolbox, but there are things that you can do that will get you a lot more out of it, right? So maybe using one bottle of active ingredient per year as opposed to two, right? So the first thing I'll talk about here is formulations and drift, right? When you're picking out, formulation and tools. When you're picking out what it is that you're going to spray, you absolutely need to pay attention to what it is recommended for, right? What pest it's recommended for, and then also what it's recommended to be sprayed on. Now, people really often overlook these things, but the label of pesticides is the law, right? And even using something that is considered to be pretty benign, right? Neem oil is considered to be pretty safe. Using it incorrectly, using it for the wrong pest species and the wrong plants can do all the things that the EPA was trying to avoid, right? So make sure that the active ingredient, right, should be listed here, is the appropriate one. It's for the pest that you're using it on, and then the active ingredient is meant to be used on whatever it's listing. So roses, flowers, house plants here. Okay. Something else you want to keep in mind: just because the products look the same or very similar, you really need to take a look at the active ingredient listing, because if I did something like bought this smaller bottle of neem oil to refill my spray bottle of neem oil, I would be accidentally putting 70% neem oil, active ingredient, into this bottle, right? So what is that? That's almost 100 times more concentrated than this product is. So you better believe that's going to cause some problems. When you're choosing what to spray with, I would go with a horticulture grade spray bottle. If you only have, recycled bottles like Windex at home, if you rinse them out thoroughly, that's fine. The reason I recommend spray bottles that are specific to use on plants is because they can produce a finer mist, and having that really fine mist is important because it allows the leaf or the flower or what have you to be more covered and more coated in the active ingredient, right? And the active ingredient needs to come into contact with the insect for it to do its job, right? Okay, preventing drift. Drift is any time that we have a spray, doesn't matter if it's an herbicide or pesticide or a miticide, but we are spraying one plant, right? And it is accidentally drifting, as it were, over to an off-target species, right? Drift happens in one of three, because of one of three factors. It happens because there's wind present, because the droplet size is very small, and because you are spraying very far away from the plants. Now, I mentioned earlier that I want that fine mist, right, from my neem oil spray, from whatever I'm spraying it in. So that means that this is kind of hard to anticipate for, right? You shouldn't be making a sprayer spray huge droplets just so that you can spray on a windy day far away. Okay, no, it's just a limitation that you're going to have to work in. So that means is if you can't control this, you're going to have to control this and this. So spray on the day where it is not windy. And when you are spraying, spray very close to what it is that you're spraying on. So if you're spraying a particular leaf or particular canopy, spray as close as possible so that there isn't any distance for the wind to take that very fine mist away. And if you can, wait for it to not be during a rainy season. When to spray? As a general rule, right, predators are more active than prey when the temperature is warmer. So to make a spray more effective, to make it safer, to maybe reduce the amount of predators that you're eradicating, you're going to want to err on the side of caution and spray when the temperatures are cool in the day. So that's the very, very beginning or the very, very end, right? As we can see here, right, we look at, this is the relative activity, right, going up and down, relative activity of this particular pollinator, right? And we're finding that the activity is increasing until it reaches a peak, and then it's decreasing afterwards, right? Well, the temperature in the day does not increase, and then increase all the way up, right? What usually happens is it increases up to midday, and then it decreases back down after the sun begins to set, okay? So you want to keep it down around here. Pest insects tend to be on the plant a lot more often than prey insects. So that's another good reason. So I'm just gonna check where are we at on time. Just want to make sure we have ample time here.
Yeah, we've got, let's start questions no later than 2:50.
Excellent. We have more than enough time. Okay, the other set of tools in our toolbox, changing our cultural practices. Pruning techniques, particularly bud removal and thinning, are really, really, really important, right? Bud removal, right, which is deadheading, right? I'm removing this spent cone flower, and thinning, which would be removing the flowers before they bloom or taking leaves off. Now, these two techniques, they don't actually reduce pests. They don't actually reduce your need to spray. But what they're doing is keeping the plant very vigorous, and they're keeping the plant very healthy. The number one thing that a pest organism loves is a weak dying or weak stressed plant. So by keeping your plants growing vigorously, you're going to keep them strong, and they can internally resist infestation. Cultivar selection is also really important. We talked about, in the environment being this big thing that we have to control within our grass, but you also want to make sure that if you are having very, very specific pest problems, so like a fusarium wilt, right, on tomatoes, maybe instead of trying to find some kind of soil fungus predator insect that you're going to release because you're going to count the fungal spores on a bacterial plate, maybe you just switch to a different cultivar, a different variety of that plant, right, that tomato that is resistant or that's tolerant. And then this issue of irrigation, right? Remember I said early on that a horticultural pest is any organism that we don't want. So if you are irrigating overhead and you're getting your flowers and your leaves and your buds wet, right, very often, that perpetually moist leaf and flower are going to start to create little edemas and little bits of rotting plant tissue. And that is the perfect place for bacterial and for fungal spores to settle in. So by switching your irrigation practice from an overhead to either a drip irrigation or just watering at the base, right? So I use a big watering extension, garden hose extension, and I water directly at the base. You want to keep your flowers, and you want to keep your leaves of your canopy as dry as possible. All right. And then this other issue of conserving and creating habitat, the last tool in our toolbox, right? Just a great rule of thumb for all gardens. I mean, just from a design perspective, from an ecological perspective, and a fascination perspective, increase your biodiversity. Plant lots of different things. I am the worst culprit when it comes to herb gardening because I like to grow basil. You know, it's easy. I know exactly what I'm going to do with it, but I should probably start growing some other things, because what you're doing when you limit, you know, biodiversity in an area is that you are increasing the environmental signal to pest species that if they come to this area, they're going to be at a buffet, right? Not to say that they won't go there anyway if you're not growing a lot of them, but the communication that it's receiving, either because it can smell or it can otherwise sense the plant, that's going to increase your odds of getting an infestation in the first place. Avoid over tillage, right? So tillage is anytime we turn the soil to bury weed seed or to refresh the texture. When kept to a minimum, tillage can be okay. A lot of people are adopting low till or no till practices, but avoiding over tillage and being able to balance how much you're doing is really important, because a lot of the predator insects that we're interested in conserving are going to shelter themselves underground. So that ground beetle, for example, it's pretty much all in the name. It's a ground beetle, right? So if you can avoid disturbing its living quarters, it will overwinter. It can successfully prey upon insects and reproduce for the next generation. Artificial habitats. I put this in here just to broach it as a conversation, as a long-term conversation. The products that are available at garden centers for artificial predator and pollinator habitat tend to be very, very small and not adequate. So while they can be an effective approach, they are not often the right dimensions. They're not often the right size. So make sure that if you are going to purchase one of these products, that you're double checking that it's big enough for the species that you're trying to preserve, right? If you just buy like a little bee hotel or something like that and pop it out in the wild, you really can't be sure if it's working unless you're going out and checking on it. I would actually start in the reverse, right? So figure out what pest species it is that you have, right? We talked about the first couple steps of IPM. Figure out what pest species you have. Try to identify a relevant predator that you know is going to be in that area, right? And then try to gain some kind of insight, whether you're talking to an extension agent or you're doing some research on your own. Try to get some insight into what would be an appropriate size for an artificial environment. And then lastly, we can use evidence-based native plantings. I put this qualifier here of evidence-based because there is just so much, there's just a cornucopia of information out there regarding basically claims that people will make saying, you know, if you plant this next to this, it stops this, or if you plant this plant next to this plant, you'll never get any fill in the blank, right? And as a horticulture scientist, I can't help but pull the thread on that whenever I can and look for the receipts, right? If something tells me that it's going to attract lacewings, I am going to look up the species of that plant by its scientific name, Daucus carota, for example, Linnaeus, right? And then I'm going to look up the scientific name for the species of insect that it's claiming to attract. And if I can't find any actual data, no one's ever done a study on that, no one can even give me an estimate of how many plants of these I should be planting to attract how many insects, I'm going to write that off pretty quickly. And so that's what I suggest to you, right? Kind of along the same lines as the artificial habitat. Take these recommendations with a grain of salt and look for the receipts. You got to look for the receipts. If I see someone's done their due diligence and they've cited the study on Queen Anne's lace ability to attract tachinid flies, good to go, right? But there's got to be something there to satisfy that evidence-based part. All right, so let's say that we've got all this fantastic information. Great, wow, you know, we're going to improve biodiversity. We're going to avoid tillage. You know, we're going to practice good garden hygiene. Well, what do you do if you're an indoor gardener? I have maybe 300 square feet inside of my house covered head to toe in plants. And just because the plants go inside doesn't mean that the pests stay outside. So what can you do? Well, one, the easiest way to bring pests into the home is on the plant itself. So if you're purchasing something, or if you are bringing it in for the season, for overwintering, for example, you absolutely need to go head to toe on the plant. I've said before that it's really not reasonable to, oh, yep, we're gonna start wrapping up here. Oh, I'm so sorry. I did not realize that was the time. Okay, so we're just gonna get through the last couple slides here. What time is it now?
2:49, 2:50?
2:49, 2:50. Okay.
Yeah.
Okay. So suffice to say, be really diligent, right? Check the plants for insects ahead of time. If you can, right, put them outside on warm, sunny days because it will disrupt the living conditions of that insect and stress them out a little bit, whereas the plant tends to be a little bit tougher. If you can't get the insects off of them completely, try to quarantine it in a modified environment, right? We're thinking warm, we're thinking very sunny. That'll help the plant out. I've got some more information on this slide set, but we're going to get into questions a little bit. Predator products are not, I mean, unless you're a commercial grower and you're trying to protect the bottom line, they're really not necessary, right? But if you're interested, they are available to purchase. As you're doing your own research after this, make sure that you're using good information, high quality information, because using poor information is actually worse than not doing anything. Because as I said before, not doing anything sometimes is the best thing that you can do. So use the things like extension publications, contact the conservation district, especially CISMA, the Center for Invasive Species. Contact extension agents, use the ID services that are provided by the state. That's just a little bit of extra information that I was going to use if we had more time. If you want to see a great example that's coming up in the future of IPM and predator management in practice, check out the Veterans Therapy Garden. We are wrapping up the design phase right now, and we expect to be constructing the garden this spring. And that's my plug. I have put together some links here for you to use if you have any lingering questions after today's presentation, especially this little database right here, evidence-based native plants for predators. If you are looking for any information at all, regardless of whether it's IPM, plants, insects, anything, if you just want someone to answer a burning question that you have, this extension article search engine is really great, or you can actually talk to somebody with our Ask an Expert system or Ask Extension system. Okay, and with that, I will go ahead and open it up for questions.
Awesome. Thanks so much, Chris. You can go ahead and leave this slide up so people can take down all of the really great resources that you've put together here. Just want to give everybody an opportunity to get their questions typed in. And so remember, you can put a question in the Q&A feature down at the bottom, clicking Q&A, or you can type it into the chat, whichever makes sense. Ask some questions about your own garden or some clarifying questions throughout the presentation, whatever came up to you throughout. While we're waiting for those, Chris, I am interested on what recommendations you might have on keeping track of management, whether it's the cultural or mechanical, chemical, whatever, yep. Keeping track of that throughout a season and throughout seasons.
So if you want to keep things low tech, I mean, and this is a recommendation I make for everything. The number one thing that you can do in terms of keeping track of pests and control strategies and things like that, get a gardening journal, right? You are fighting an uphill battle if you're trying to improve your skills as a gardener, as a rancher, if you're not keeping track of things like when certain species are appearing on your farm or your garden during what dates. Just starting with that information alone, if that's the only thing that you ever keep track of, is a calendar of when you first noticed aphids on your tomatoes, that will put you light years ahead of where you've ever been, right? If you're a huge nerd like me, I got my glasses in Florida. If you're a huge nerd like me, use a spreadsheet, use an Excel spreadsheet, right? if you have an office, a home computer, just make some notes in your notebook, but then transcribe them into the spreadsheet. If some of you use spreadsheets a lot, you'll know that you can do things like look at the data afterwards and find when species are booming. And yeah, so it looks like we've got some questions in the chat. I'm going to answer this one live. Is rotation of vegetable plants beneficial to reduce prey? Yes, that's correct. So rotating where in the garden you are growing your vegetables is super important, especially as it relates to soil-borne organisms. So if there's an insect which is flying or which is highly motile, it's highly mobile, it's not going to do quite as much because it'll have overwintered nearby and it can just go over. But if you find that you're having a lot of problems with soil bacterial or soil fungal pressure, moving where you put that particular crop stand, those particular vegetables in the garden is very, very effective. As long as you are rotating between vegetable families, so going between the nightshades and the cucurbits, for example. So doing tomatoes or peppers one year and then squash or cucumbers the next. That's a good rotation, right? Okay. White pine weevils destroying terminal shoot of 15 tall trees. Okay. So what I suggest that you do is you hop on to either the Ask an Expert tool that I've got here, or take a look at the search engine, the extension article search engine. I'm a horticulturist. I'm not an entomologist, so I always try to kind of draw a perimeter around where my expertise ends, and 15 feet above the ground is about it. So
I think that's fair. Let's see, what time is it? We do have time for another question or two. So if something's burning in your mind, or if you're like, oh, I don't know if that's really the question I wanted to ask, go ahead and ask it because we've got the time.
Yeah. And if not, I'll let you look at this piece that we really didn't have any time to talk about. This is a really fascinating bit of technology. Basically, what researchers have done is that they've taken this handy dandy little yellow card here, and by taking a picture of it with just a regular DSLR, or I think this is a webcam, they have computer software now that will literally identify the insect that it's looking at and then count it, tabulate it, and then graphically track the changes in the insect population. So this is IPM on steroids, right? This is napalm. This is not something that you need for your garden, but this is really just to illustrate where we are at the state of the technology now.
Wow, very cool.
All right. Oh, black fungus on a young silver maple. Is that a Stevie Nicks song? Black fungus on a young silver maple could be a number of things. I'd say if you can get a picture of it, jump on that Ask an Expert or Ask Extension tool. Send your picture in, include a description of the area, include a description of anything you've done recently, and they'll be able to put you in touch with someone who maybe specializes in maple tree diseases. Weeping larch, very attractive to Japanese beetles. How do you control? I believe there is there's a biological product that can be used on Japanese beetles, but it is not labeled for consumer application. You're gonna have to talk to a landscape pest applicator, make sure that they're licensed for that particular product, and that they're able to spray it based on where you're at. Because if you have a tree next to very, very close to your neighbor, for example, or very, very close to an edible agricultural farm stand, probably not going to be able to get that sprayed.
Very good. All right, I want to be respectful of everybody's time and get wrapped up. Thank you, everybody, for the great questions. Thank you so much, Chris, for a great presentation. And thank you for attending this session of the Van Buren Conservation District's Backyard Symposium webinar series. We hope you'll join us for more of these sessions. Remember that you can message us using the contact form on our website, vanburencd.org/contact-2, or you can sign up for our newsletter using the subscribe option at the bottom of our website. This webinar is being recorded, and recorded webinars will be posted next week at youtube.com/user/VanBurenCD/videos. Remember, you can follow us on Facebook at Van Buren CD, and we are continuing this series. Tomorrow will be Christopher Swinson's Introduction to the Mushrooms of Michigan. I saw him speak at Liberty Hyde Bailey last year, and it was excellent. I suggest you come by tomorrow. Thanks again, Chris, and thank you everybody for joining us.
I'm going to stay on for a second just to